Good day, everyone. It's a great opportunity to be part on this educational webinar that tackles about PLC programming. The speaker gave us lots of knowledge that gets me excited to be involved and dive deeper into PLC programming. The speaker said that PLC, or the Programmable Logic Controller, is one of the promising area of computer engineering. As a computer engineering student, without knowing it in the first place, it gets me excited to know more about this field. PLC is a digital operating electronic system apparatus, which uses a programmable memory for internal storage of instruction for implementing specific functions such as logic sequencing, timing, counting, and arithmetic control through analog or digital input-output modules, various types of machines or processes. The purpose of programmable logic controllers are initially designed to replace relay logic boards, accepts input from a series of switches, and sends output to devices or relays. PLC was introduced in late 1960s. The first commercial and successful programmable PLC was designed and developed by Modicon as a relay replacer for General Motors. The PLC are easy to program. It does not need rewiring on the control system if you will change the program. Smaller size but high reliability, simple construction and low maintenance, and cost competitive. Industrial automation began long before PLCs. In the early to mid 1900s, automation was usually done using complicated electromechanical relay circuits. However, the amount of relays, wires, and space needed to create even simple automation was problematic. Thousands of relays could be necessary to automate a simple factory process. The disadvantages of a relay control system are it is complex, costly, hard wiring, logistic nightmare, troubleshooting problem. If one of the relays malfunctions, it is difficult to know which one has a problem. Strict maintenance routine, and it is not easy to modify. PLCs vary in size and form factors. Some are small enough to fit in your pocket, while others are large enough to require their own heavy-duty racks to mount. Some PLCs can be customized with back planes and functional modules to fit different types of industrial applications. PLCs are widely used in a variety of industries because they are fast, easy to operate, and are considered easy to program. Depending on the inputs and outputs, a PLC can monitor and record runtime data, such as machine productivity or operating temperature, automatically start and stop processes, generate alarms if a machine malfunctions, and more. PLC are flexible and robust control solution, adaptable to almost any application. The PLC was designed to be easily programmable by the plant engineers and technicians that were already familiar with relay logic and control schematic. Since the beginning, PLCs have been programmable using ladder logic, which was designed to mimic control circuit schematics. The ladder diagrams look like control circuits where power is flowing from left to right through close contacts to energize the relay coil. Ladder logic looks like simple control circuit schematics where input sources like switches, push buttons, proximity sensors, and etc. are shown on the left and output sources are shown on the right. The ability to program complicated automated processes with an intuitive interface like ladder logic made the transition from relay logic to PLCs much simpler for many in the industry. PLCs are used in various applications in industries such as the steel industry, automobile industry, chemical industry, and the energy sector. The scope of PLCs dramatically increases based on the development of all the various technologies where it is applied. Although the first PLCs were very limited in their memory and speed capabilities, they quickly improve over the years. The presence of PLCs helps simplify the design and implementation of industrial automation. How industrial automation helps to mitigate the impact of climate change. The impacts of climate change are worsening each year, and thus we should look for ways of fighting these changes. We are constantly experiencing extreme natural disasters and temperature fluctuations that are sweeping across our world. Animals and plants are adversely affected by these climate fluctuations, with delicate crops and species dying in extreme drought and heat. If carefully managed, changes in production and consumption patterns could create environmental improvements compared with the processes used today. But without proper environmental objectives and management systems, automation alone could have significant adverse impacts, especially on energy use and emissions generated from the current energy mix, resource use, and ecosystem. There are no upfront guarantees. New technology, new technological capabilities like industrial automation will automatically foster environmental sustainability. The forthcoming disruptive technologies are double-edged swords that may generate diverse outcomes based on the intentions and skills of their users. Thus, it's a good time to explore the linkages between these new technologies, the changing economic premises that will accompany their deployment, emerging patterns of production and consumption, and their potential environmental and social impacts. Such an inquiry may be guided by, even if not limited to, global aspirations to reach the Sustainable Development Goals. Thank you.